Okay, sorry about that. So integral from 1 to 3 of 3x squared minus 4x plus 1. Well, let's see. First we're going to start by taking the integral of this. So integral of this, well, it's just a polynomial. So 3x squared, integral becomes 3x cubed divided by the new power minus 4x squared divided by the new power plus x divided by the new power divided by 1. Whatever constants come from just x. Right? So 1 is just going to be 1x. And take the integral. Right? But more than that, I've got integral from 1 to 3, so I need to evaluate this at 1 and 3. And I can rewrite this. 3's cancel, get x cubed minus 2 is going to cancel, so therefore it simplifies to 2x squared plus x from 1 to 3. So this means to evaluate it from 1 to 3 means I'm going to take it at 3. So plug in 3 here. And then I'm going to subtract what happens if I plug in 1 here. Okay. And you end up finding this will be, what, 1 minus 2 plus 1. It's actually going to be 0 over there. And over here, we end up getting, let's see, this will be 27 minus, let's see, it's 9 times 2 minus 18 plus 3. So all that minus 0, so what does this end up getting us? 12? I believe. Let me double check that. Yeah. Yep. The answer ends up being 12. Okay. So that was number 2. Now number 3. I want to find the integral of x cubed e to the x. Excuse me, x squared e to the x. Alright. So I look at this one, I notice, alright, I've got e to the x over here, and I've got x squared. So if I tried u substitution, if I make u x, well, the derivative of that's just 1. This x squared still needs to cancel. If I make it x squared, well, the derivative is just going to be 2x. Well, that's not going to cancel this x up here. So what I have to do is I have to use integration by parts. Because if you try u substitution, you try it, you find it doesn't really work. Alright. So if we're using the tabular method here, my d column and my I column, now I need to determine what goes in the d column, what goes in the I column. Well, derivatives of x squared, that's easy. Derivatives of e to the x, that's easy. I column, well, I know e to the x, that's way easier to integrate, so it's going to be e to the x the whole time. X squared takes derivatives. So you get a polynomial times an exponential. You're always going to put the exponential in the I column. Right. So derivative of x squared is 2x. Derivative of that is 2. Derivative of that is 0. And e to the x, you integrate. You just keep getting e to the x. Okay. So we get plus, minus, minus. And this one should be an integral. Draw our arrows diagonally, and the last one straight across. Okay, so this gives us plus, so we should get x squared times e to the x, there's that, minus 2x e to the x, that, plus 2e to the x, minus, what's this one going to be? Oh, that's just going to be a constant, right? So integral of 0, well, it's a constant. So I could say minus or plus c. Either way, c is just a constant. So there's number 3. Alternatively, you could do the long way of integration by parts. You end up having to do it twice. It should simplify to the same answer. Number 4. Use graphical geometric interpretation of definite derivatives to determine this guy, and I forgot to draw the graph right here. Alright. What I had, let me go grab. Apologize, I just printed off a fresh copy. I don't want to. Okay. So I ended up with 1, 2, 3, 4, 5. Okay. Okay. So I'm saying that this graph right here is in fact the graph of f of x. Okay. So find this definite derivative if this is the graph of f of x. Okay. So from 0 to 3. So what that represents is the area underneath this curve, underneath these lines, between 0 and 3. So I put this dotted line in here as a hint, and to show that that's where this changes from one line to another. So from up to here, well, that's a triangle, right? So the area under this part of the line is going to be, the height here is 2, the width here is 2, so area of the triangle here, just put a triangle, is going to be 1/2 times the base times the height. That is the area underneath here. Okay. Also, you could look at this as, well, there's a square right here. Cut it in half, you get this triangle. Either way, this area should be 2. But I'm looking for the integral from 0 to 3. So that's just this first part. I need this last part, which is a rectangle, height 2, and width 1. So the area of the rectangle, we'll say, is 2 times 1, length times width, equals 2. So overall, that should be the area underneath this curve here, and that is, in fact, the definite integral from 0 to 3 of f of x dx. What I'm really looking for here is when I say graphical or geometric interpretation, I need to know that I'm looking for the area underneath the curve. So if you do nothing more than shade the area under the curve, that should earn you points, and that should be worth something at least. Right? So this question was missed a lot, so I wanted to clarify that geometric interpretation means look under the curve here. Right? And we're assuming that this is the graph of f of x.